Arizona State University's Cloud Innovation Center collaborated with City of Phoenix Street Transportation Department to create an open source tool that generates a sidewalk inventory of a city using aerial drone imagery, object detection, AWS cloud infrastructure, and GIS tools. To view the supporting artifacts and the source code for this challenge, please visit our website smartchallenges.asu.edu and navigate to the Challenges tab. You'll find the CurbPHX sidewalk inventory in here and all the related documentation for this project. We created this dashboard to interact with the application. It gives a brief introduction to our challenge. Clicking on Get Started Now, you must select a data source, which is EagleView for this instance. In here, it requires two URLs to the images, location, and the metadata file. These both are hosted on Amazon S3 and are required to do so. Once you click on Begin Process, it'll start the application loop. I would like to show you the Amazon S3 bucket which we use for this demonstration. It contains a folder called Images, which has all the images that will be used for the detection purpose. And it also contains a metadata XML file. This file contains the information about all images in the folder. The format for this file will be mentioned in the deployment README documentation file in the GitHub repository. Once the process has completed, we see that Go to Downloads button is enabled. It navigates us to the next page, which has various options to consume the sidewalk detection output. First, we have a link to another dashboard, which hosts the Google Maps service and draws the detected sidewalks output appropriately. Second, we have a download link to a shapefile if you're using ArcGIS and a download link to a XML file if you are accustomed to the Google Maps format. The Google overlay displays the output detected by the application. If I zoom in, I can see there are a couple of different lines. The red line indicates areas where there are no sidewalks detected. The orange lines are areas where attached sidewalks are detected. These sidewalks are directly attached to the roads and are considered moderately safe. The green lines represent detached sidewalks. They have a separation between the road and the sidewalks themselves and are considered the safest option. To explain in brief how our cloud application performs, we take a large image set and we filter it down to least number of images that cover the entire area. Each image is then separated into 9 equally sized chunks, which is then processed by our image recognition model. The output generated is then displayed on a Google overlay or available to download as a shapefile or a KML file. To know more about our project, you can go to our GitHub repository ASU CIC repo/CurbPHX. That's CurbPHX. Finally, I'd like to thank you for watching this demo of the CurbPHX sidewalk inventory.